Good morning. Today is October 3rd, 2022, and I'm broadcasting from my office bedroom or my bedroom office. It's the only place in the house I have except in the living room, and that doesn't work. I want to share a robotic reading of an article about rainfall in Greenland on top of a mountain where it doesn't normally rain, but with global warming it now rains and it causes ice to melt faster. Incidentally, take politicians' behavior as personal attacks upon me and this planet I call home, and future generations must call home. And all of this climate damage does not get paid for by these old white gray-haired old men that make decisions about where our nation's resources go. They are in touch with big money, people who want money to make money. That's a fact. It is worse today. And global warming is worse today, and it's not going to get any better in anybody's lifetime.
Greenland ice sheet rainfall, heat and albedo feedback impacts from the mid-August 2021 atmospheric river. Abstract. Rainfall at the Greenland ice sheet summit August 14, 2021, was delivered by an atmospheric river, air. Extreme surface ablation expanded the all-Greenland bare ice area to near record high, with snowline climbing up to 788 plus or minus 90 m. Ice sheet wet snow extent reached 46%, a record high for the 15 to 31 August AMSR data since 2003. Heat-driven fear deflation averaged 0.14 plus or minus 0.05 m at 4 accumulation area automatic weather stations, AWS. Energy budget calculations from AWS data indicate that surface heating from rainfall is much smaller than from either the sensible, latent, net long-wave or solar energy fluxes. Sensitivity tests show that without the heat-driven snow darkening, melt at 1,840 m would have totaled 28% less. Similarly, at 1,270 m elevation, without the bare ice exposure, melting would have been 51% less. Proglacial river discharge was the highest on record since 2006 for late August and confirms the melt-sustaining effect of the albedo feedback. Key points. A mid-August 2021, Greenland atmospheric river, AR, produced extreme ice sheet snow cover changes and high proglacial river discharge. Surface heating from rainfall is small compared to latent and sensible heating, net long-wave radiation or sunlight absorption. Melt albedo feedback enhanced upper elevation snowmelt under clear skies following the heating delivered by the AR. Plain language summary. While rainfall at Summit Station atop of the Greenland ice sheet in mid-August 2021 captured global attention, its direct surface thermal effects were weak and unable to explain the major melt and river discharge that occurred during and after the event. Exceptional heating of the ice sheet first occurred due to the heat transfer from condensation and the elevated air temperature during an atmospheric river, AR, episode. Satellite measurements reveal a rapid retreat of the snowline to higher elevations, exposing a large extent of relatively dark bare ice. Where snow remained, darkening due to wet snow metamorphism was responsible for sustained additional solar heating of the upper ice sheet elevations for the following 2 weeks. Observations from automatic weather stations and satellites, and river gauging, reveal that the AR had an immediate and sustained impact. 1. Introduction. On August 14, 2021, news headlines reported that rainfall was witnessed for the first time at Summit Station near the highest point of the Greenland ice sheet, Ramirez, 2021, and was accompanied by high surface melt extent, Scambos et al., 2021. Greenland rainfall can be delivered as part of concentrated poleward transport of moisture and heat in atmospheric rivers, ARs. Neff et al., 2014, identified ARs promoting Greenland melting by movement of air masses over the ocean with upstream development over the 2012 summer North American heat wave. The 2012 ARs were responsible for the largest observed single-day Greenland surface ice ablation rate of 0.28 m day-1, Fausto, Van Es, Box, Colgan, and Langen, 2016, Fausto, Van Es, Box, Colgan, Langen, and Mottram, 2000.